Hello dear students, welcome to Tejama YouTube channel. In the last video we have discussed about 5 numerical questions from the chapter wave optics. Let us solve few more questions from the same chapter, that is wave optics, on the experiment Young's double slit experiment. Okay, so here we have the sixth question, that is in Young's double slit experiment, distance between the slits is 0.5 millimeter when the screen is kept at a distance 100 centimeter from the slits. The distance of ninth bright fringe from the central fringe system is 8.835 millimeter. Find the wavelength of light used. So if you consider Young's double slit experiment, the setup looks like this. Okay, so this is this screen. Here we have slit S1, slit S2, distance between the slits is small d, distance between the screen and the slits is capital D. So here we have this main source S, and here we have central bright fringe, and after that consecutive bright and dark fringes will be there on either side with equal fringe width. Now if you consider the data, what is given in Young's double slit experiment, the distance between the slits, that is small d, is given. Small d value is 0.5 millimeter. Okay, when the screen is kept at a distance 100 centimeter, that is 100 into 10 to the power minus 2 meter, nothing but 1 meter. 100 centimeter means 1 meter. From the slits, the distance of ninth bright fringe from the central bright fringe is, means distance of nth bright fringe is given by n lambda d by small d. So where distance of ninth bright fringe is given, that is 8.835 millimeter, 10 to the power minus 3 meter. What is the wavelength of light used? Means we need to find out lambda. Okay, now xn is given, n is given, lambda is given, capital D is given. So if we substitute the data and calculate lambda value, you will get xn into small d divided by n into capital D. So that is equal to, what is xn? Distance of ninth bright fringe on the screen, you can consider it as y also. So that is 8.835 into 10 to the power minus 3 into 0.5 small d value into 10 to the power minus 3 divided by n value is ninth bright fringe, capital D value is 1 meter. If we solve this, you will get around 4.9083 into 10 to the power minus 7 meter, or you will get 490.83 millimeter. Therefore lambda used is 490.83 millimeter. Sorry, this should be nanometer, no? Nanometer. Yeah, this is the answer. Shall I move to the next question? Yes. Here we have in Young's double slit experiment, the distance of the screen from the double slit is 2 meter. When the wavelength of light or a light of wavelength 550 nanometer is incident on the double slit, fringes of width 2 millimeter are obtained. Determine the separation between the slits, means we need to find out small d value. Separation between the slits means small d value we have to find. Find the fringe width when the light of wavelength 400 nanometer is used. So let us write the data here. So in Young's double slit experiment, the distance of the screen from the slits is capital D is 2 meter. When the light of wavelength lambda is equal to 550 nanometer, here two wavelengths are given, so I'll consider it as lambda 1. The incident on this double slits, the fringe width is obtained. How much? Beta 1 is equal to 2 millimeter, 10 to the power minus 3 meter are obtained. Determine the separation between the slits. Small d is equal to how much? This is the first question. Sub question is, find the fringe width when the light of wavelength 400 nanometer is used. So for example, if you consider, if we consider 400 nanometer wavelengths, that is lambda 2 is equal to 400. Nano means how much? 10 to the power minus 9 meter is used. So what will be the fringe width? I'll consider this as case 1. This is case 2. First, let us find the small d value. Since we know that fringe width formula is beta is equal to lambda capital D by small d. So we need to find out small d, or d is equal to lambda d by beta. For lambda 1 we have beta 1 and into capital D. So small d is equal to lambda 1 is how much? 550 nanometer into capital D 2 meters divided by beta 1 is how much? 2 millimeter. So if we solve, beta small d value will get 0.2 to get cancelled, 0.55 millimeter, or into 10 to the power minus 3 meter, millimeter, or 10 to the power minus 3 meter. This is case 1. Case 2, we need to find out fringe width beta 2. For that, lambda 2 d divided by small d will be there. Lambda 2 is how much? 400 nanometer minus 9 into small d is, sorry, capital D is 2 divided by small d is 0.55 into 10 to the power minus 3. Around how much will get? Beta 2 is equal to 1.45 into 10 to the power minus 3 meter. You can use the calculator and solve this, or directly also you can calculate and find the answer. You will get 1.45 millimeter. So this is about this question. Hope we have understood the answer explanation. We'll move on to the next question. This is the 8th question, in which we have in Young's double slit experiment, the slits are separated by 0.28 millimeter and the screen is placed at a distance 1.4 meter away from the slits. The distance between the central bright fringe and the fifth dark fringe is measured to be 1.35 centimeter. Calculate the wavelength of light used. Also find the fringe width if the screen is moved 0.4 meter towards the slits from the same experimental setup. So here let me write the data. In Young's double slit experiment, the slits are separated by 0.28 millimeter. So small d is 0.28 into 10 to the power minus 3 meter, and the screen is placed at a distance capital D is equal to 1.4 meter away from the slits. The distance between the central bright fringe and the fifth dark fringe is given. Xn for fifth dark fringe is given by 2n minus 1 lambda t by small d into 2. So this value is given, that is x5 is 1.35 into 10 to the power minus 2 meter. You can write y5 also, yn also. Calculate the wavelength of light used. So what is lambda? So here also we need to find the fringe width. Beta value is equal to how much? If the screen is moved 0.4 meter towards the slits, means capital D dash becomes 1.4 earlier minus 0.4, that is 1 meter. For capital D is equal to 1 meter, what will be the fringe width? That also we need to calculate. So here we need to find out what lambda. Case 1, lambda is equal to, what do you get from this formula? 2 small d into xn divided by 2n minus 1 into capital D. That is equal to 2 into small d is 0.28 into 10 to the power minus 3 into xn is 1.35 into 10 to the power minus 2 divided by 2 into 5 minus 1 into capital D is 0.28 into 10 to the power minus 3. So if you calculate this, you will get somewhere around 6 into 10 to the power minus 7 meter, that is 6000 angstrom. Okay. Case 2, we need to find out fringe width. Beta dash is equal to lambda is same, d dash divided by small d. Lambda we have found, that is 6000 angstrom or 600 nanometer, whichever you want you can write, into d dash is 1 meter divided by small d is given, right, 0.28 into 10 to the power minus 3. So if you calculate this, you will get somewhere around 0.0214 meter, that is 21.4 millimeter. Okay na? So this is about this question. So consider this question as a homework question. Try to answer it. We'll meet you in the next video with much more content. Thank you.